Hello everyone, I'm Talat YAVUZ. I'm an electrical and electronics engineering student at Bilkent University. Today I will perform my PHYS102 final project experiment. We need some equipments. Firstly, a precision scale, two magnets and its plastic base, a conductor holder, two crocodile cables, a power supply, and a Gauss meter. Then we will arrange such a system to measure the magnetic force on the conductor by using Newton's third law, which is action-reaction law. It states that if the rod conductor has upward magnetic force, then magnet-plastic system has downward reaction force, and the precision scale will show us the gain in weight. The aim of my experiment is exploring the magnetic force on current carrying wires in magnetic fields and observe magnetic fields depends on what and how its direction affected by changing magnetic field's direction and current direction. Firstly, we want to see the direction of the magnetic force is determined by right-hand rule. Our current direction is that, magnetic field is that, and magnetic force is downward, reaction force upward, which means losing weight. And when we change the direction of the current, it becomes like this and turns a gaining weight. And if we again change this time magnetic field direction, it was like that, it becomes this, and it's again losing weight. And as you can see, it's proves the Lorentz force, which is magnetic forces is equal to cross product of current times length and magnetic field. Now we will use 5 cm conductor and 2 ampere current, and we will increase the current with step 0.5 ampere until the 5 ampere and tabulate our data and plot the graph of it. We expect the graph is linear line because magnetic field between the magnets doesn't change, and we can experimentally calculate the magnitude of the magnetic field between the magnets, since we know magnetic force, we know current value, and we know the length of the conductor. The experimental magnetic field between the magnets is just slope of the best line divided by length of the conductor. Now we will set our current to the 3 ampere and we will increase our length from 1 centimeter to the 7 centimeter and observe its magnetic field and tabulate our data and plot the graph of it. Again, it's expected to a linear graph since magnetic field doesn't change between the magnets. And we can experimentally again calculate our magnetic field between the magnets just using the slope of the graph divided by current. Finally, in order to see our errors while calculating our experimental magnetic field, we will use Gauss meter to observe and measure the real magnetic field between the magnets. And calculate our error percentages. Thank you for listening. That's all.